Some more practice problems to become good at balancing redox reactions. We have C6H12O6 plus O2 becomes CO2 plus H2O. This is the aerobic respiration of glucose, and that's our redox reaction. The first step is to identify our two half reactions. So we have our oxidation and reduction reactions. We can tell that C6H12O6 and CO2 is our oxidation reaction because carbon loses hydrogen and had gained oxygen. It might not be obvious at first because we have 6 oxygen on the left and it becomes 2 on the right. Looks like it had lost some oxygen, isn't it? But if we break down C6H12O6 into its empirical form, we can see that it becomes CH2O. Now it becomes more clear that carbon had in fact gained oxygen. It went from 1 to 2. Which makes O2 and H2O our reduction reaction, and you can check. In this reaction, it gains hydrogen and loses oxygen. And a compound involved in an oxidation reaction are called reducing agents or electron donors. Meanwhile, compounds involved in a reduction reaction are called oxidizing agents or electron acceptors. The next step would be to balance the two half reactions, starting with the oxidation reaction. We can write its original equation. Now we have to balance our C's. There's 6 on the left, so we're going to have to add 6 to CO2 to get 6 carbon on the right. Then look at our O's. There's 6 on the left, 6 times 2 is 12 on the right. So we need to balance the O's on the left by adding 6 water molecules. Now that our O's are balanced, look at our H's. There's 6 times 2 is 12 on the left, plus 12 more becomes 24. So we need to balance the right side by adding 24 hydrogen ions. Finally, look at the charges. There's a total of 0 charge on the left, a plus 24 on the right. To balance the charge on the right and cancel the plus 24, we have to go ahead and add 24 electrons. Now that everything's balanced, for the first half of the reaction, we're going to do the same for the reduction reaction. Start by writing the original equation. Now look at O's. There's 2 on the left, there's 1 on the right. We have to add 1 more water molecule to balance the left and the right. H2O plus H2O can be rewritten as 2H2O. Now that our O's are balanced, look at our H's. There's 2 times 2, so 4 on the right. We need to balance the left by adding 4 hydrogen ions. Now look at the charges. There's 0 on the right. There's a plus 4 on the left. We'll have to add 4 electrons to cancel the charges. Also, one trick to ensure that you had got the oxidation reaction and reduction reaction correct is by noticing how in an oxidation reaction the electrons are added on the right, and in a reduction reaction it'll always be added on the left. Just a quick way to check. Now that our two half reactions are balanced, the next step would be to make sure our electrons are equal so that we can cancel them out in our final overall reaction equation. To get 4 electrons equal to 24, we're going to have to multiply by a factor of 6. And I'll rewrite this down here. to make it clear. Four times 6 becomes 24 electrons plus 6. 4 times 6 becomes 24 hydrogen ions plus 6 O2 and 12 H2O. Now we are ready to add the two half reactions together to get our overall reaction. Notice how the 24 electrons can cancel out. We have 6 H2O on the left, 12 on the right, so we can cancel the 6 on the left out. 12 minus 6 is 6. So we can write 6 H2O later on the right side of the equation. Since nothing cancels our C6H12O6 out, we can write it in our overall reaction. Our 24H plus also cancels out, and we keep our 6O2. And on the right side, we have 6CO2 plus 6H2O. Now we're going to check, make sure all our elements and charges are balanced. We have 6 C's on the left, 6 on the right, check. 6 O's plus 6 times 2 is 12, so 18 O's on the left. 6 times 2 is 12 plus 6 becomes 18 on the right, so check. Our H's, there's 12 H on the left, 6 times 2 is 12 on the right, check. Finally, look at our charges. There's a total of 0 charge on the left, 0 on the right, check. So now we have a balanced equation in our overall reaction equation. Notice how our overall reaction equation and our initial redox reaction equation are similar, except for now our overall reaction is balanced. So all is good.